Guys, welcome back to my YouTube channel. So far we have seen 4 examples on evaluating integrals. They were pretty simple examples. We just had to start with the power rule and some other rules, and we could just directly use them and evaluate the integrals. So no big deal. But now guys, we are going to work with some more complex and complicated functions, and then we want to see how to find or evaluate the integrals of those functions. So guys, one of the methods that helps us to evaluate integrals of those complex functions is called the method of substitution. So as you can see the word substitution. So most of the times, while we use this process, it's all about substituting and substituting. Okay. So I have broken this down into 3 parts. So if we follow these 3 parts, we should be able to use those three things and then apply it to problems. Guys, the first thing that we want to do when we are trying to use the method of substitution is we want to start by writing u as a function of x, and it will make more sense when I start actually applying it to a problem. But we start with any other variable. Okay, so it could be u, it could be y, it could be any other variable. And most of the times, although there is no hard and fast rule which function you choose as your u function, but most of the times we like to use the function which is more complex or which has a power with it. And it, guys, as I said, it will make more sense when I actually apply it to a particular problem. But that is step number 1. You start by substituting or letting u equals to some expression in terms of x. Then the step number 2 is we evaluate the derivative of that function u with respect to x. And once we do that, then we solve for dx, which is going to be once we evaluate it, then we'll be able to do that. Then guys, the step number 3 is kind of bringing this all together. What we do with that is we substitute that dx that we found in step number 2 back in the original function, and then we also substitute the value for u that we started in the step number 1. So guys, if we follow these 3 steps, we should be able to use the method of substitution. Although there is still more work that needs to be done in each problem, but we'll see those problems and we'll apply these 3 steps and see how to evaluate the integrals. Okay, so guys, without any delays, let us just look at this example number 5 and let us see how we can apply these 3 steps and evaluate the integral. So guys, looking at this function right here, you can already see that it is a more complex function than what we have seen previously. So it is really complicated. I mean, if we try to do it using the methods that we have used prior to this method of substitution, it's going to be a little more work. And of course, there's going to be functions later on that we see are we cannot really do them by the methods that we have learned previously. We have to use some new methods. And guys, method of substitution is a very important and useful method. So we're just going to try to follow the steps and let's see how far we can get with that. The step number 1 is we got to substitute. And guys, keep in mind, there's no hard and fast rule, but it is highly suggested that we start with a function that is a little more complex or has a power. So in this case, when I compare these two, I have a 4x, which is a linear function, and this is a quadratic function. And of course, we can see that it's a more complex complex function. So we're going to start with substituting. So step number 1 is we're going to say let u equals to x squared plus 1. Okay, that is step number 1. And we chose this because this has a power and this is more complex. Okay, it's like a co-function, it's a combination of several functions. So we like to start from that. Guys, once you start doing these examples, you would also be able to see other reasons why one wants to choose this function as u and not the other one. Okay, guys, step number 1 is done. The second step is pretty simple. You just have to evaluate the derivative. Let us go ahead and do that. Got to do du over dx. The derivative of this function is just simply 2x. Derivative of 1 is 0. No need to worry about it. Guys, there's an invisible 1 downstairs and we want to solve for dx. To solve for dx, obviously we want to cross multiply, and from here you get 2x dx equals to du. Du times 1 is just simply du, but we want dx by itself, so I'm going to divide both sides by 2x, and this crosses out. I get dx equals to du over 2x. So guys, I'm going to circle this because this is something I need to use, and then of course we also need this. So step number 3 is more like bringing these all together and again substituting in the original function. So I have an integral 4x. I'm not going to do anything with that, and then this, guys, right here is simply going to be substituted by u because u is x squared plus 1, the piece inside the parentheses. So it's going to be u to the power 6. And then what do I have? I have a dx, and dx is already solved in terms of du, and then there's also a 2x in the denominator. Okay. So we substituted, we already followed through the step 1, step 2, and up to step 3. Now guys, we just got to simplify and see what we can do from here. So from here, there's few things we can do. The x and x crosses out. Then 4 divided by 2 is 2, so it finally becomes 2 u to the power 6 and du. So guys, now you can see it was a more complex function. It was actually a product of functions, and there was co-functions, so many things going on, but by just simple substitution and following the steps, we were able to condense this into a simpler function. Okay, and now we know how to actually evaluate the integral of this. This is a pretty simple function. We can use the power rule on that. So you just take out that 2, then it's integral u to the power 6 du. And we already know how to use the power rule. You just have to add the 1 to the exponent. So it's 2 u to the power 6 plus 1, which is 7, and then 7 in the denominator. Of course, there's a plus c. Okay, so we are, guys, almost done. But here's the thing. The original function is in terms of x. So we cannot have the final evaluated integral or final answer in terms of u. We have to have the final integral also in terms of the x. And that's a very easy piece. Again, it is all about substituting. And guys, the method of substitution, is all about substituting. So even at the last step, what we have to do is, wherever we have the u, we already know that u in terms of x is x squared plus 1. So we got to substitute for u as x squared plus 1. Of course, there's a raised to the power 7. There's a 7 downstairs. And don't forget that plus c. We are still working in the indefinite integrals. So guys, that is it. This is the integral for this function. And now, if you want to convince yourselves that this is actually the correct answer, all we have to do is we have to take the derivative of this function, and once we take the derivative, if we get back this function, then we are convinced that this is the integral for this given function. And we already know how that works because we know the basic idea of integration and derivatives. Like antiderivatives are the reverse process of derivatives. Okay, so guys, I'm not going to do that right here, but if you want to convince yourselves, please go ahead and try doing that. This is example 5, guys. These are the steps, and we're going to keep on using these steps for a lot of different examples using the substitution method. So guys, keep practicing these methods, and I will see you in the next video with another example.